Hi, today we're going to look at how to take backups and restore them in Microsoft SQL Server 2008 R2. The ability to take backups and be able to restore them is critical if you're a DBA. In fact, it's one of the most critical skill sets that any DBA is expected to have. Now, while this might seem simple, for the most part, DBAs often make mistakes when taking backups or restoring them because they haven't really thought it through. A key thing to remember here is that the same backup solution or strategy doesn't work for everybody. And more often than not, the kind of backups that you take will decide if you're still going to be able to restore them and what kind of data loss you can expect as part of the restore operation. A DBA is expected to know this. However, it is critical to remember that there is a lot of database internals involved as part of a database backup, and it's not simply a matter of taking the backup using the interface. In fact, for the most part, DBAs don't really use the interface to take backups anymore. They use a lot of third-party tools such as Lightspeed, etc. to go ahead and take the backups for them. However, in the event that some of these operations fail or you're not able to do the backups using these technologies, it is still expected that the DBA should be aware or should be familiar with how to take a backup using the Management Studio interface or using the transact SQL commands. Before we really get into the actual database backup and restore operation, let's quickly look at the internals, or let's try to understand what goes on with a backup. Now, as far as a database is concerned, there are really critically two important parts to it, and the first part is the actual database files. Every database by default is expecting two files, which are the log file and the data file. Now, if you look at it, the AdventureWorks database that we have here has a data file and a log file, and then it's got a secondary log file as well, which belongs to a secondary file group. The way to differentiate between primary files and secondary files is by their extension. A primary file usually has an extension MDF, and a secondary file would have by default NDF. However, these extensions are not mandatory and can be changed with any other values, but for the most part, in your ability to understand them, you should stick with the standards, which is MDF for primary, NDF for secondary, and LDF for log file. The nature of the log file is different compared to the nature of the data files, in that the data file contains the actual data and does not really contain information about how the data came to that state. However, on the other hand, the log file contains the information of the state change of every data page inside the database, which means that if you have a log file, you will be able to restore a database to a point in time. By point in time, what we mean here is that if you have a log file, you should be able to restore the database to any point as long as you have a log file that contains that timestamp or the transaction that you're trying to restore to. Having said that, it's not always possible that you need a log file or you have a log file available to you at the time of performing a restore. This sometimes happens when the log file becomes corrupt or the drive that contains the log file crashes before you can take a backup. In these cases, we will actually use something called a standby or a log file, where you can just go ahead and restore the database and then generate an empty log file, or you can try and restore the database to the last known log file that you had, or the last log file that contained a transaction at which you can restore the database. These are again slightly advanced concepts, and we will talk about them in future videos. For the purpose of today's video, we are only looking at how to take a full database backup and restore it. A full database backup is a complete backup of the entire database up to the time when the database backup was taken. Now, a key thing to remember here is that a full database backup is not usually something that every DBA does. But on the other hand, knowing how to take a full backup and the ability to restore it is critical in terms of understanding the other backup and recovery options available to you as a DBA. Let's now look at the different database backup or recovery models available to us. A database by default comes with 3 different recovery models. You can find these by right-clicking on the Database Properties tab and then selecting Options and Recovery Model. As you can see here, the database has basically got three different recovery models available. The first being full, the next being bulk logged, and the last being simple. The main difference between these three different recovery models is that a full database recovery model allows you to go ahead and restore the database to a point in time. A bulk logged recovery model allows you to go ahead and do a minimally logged operation when you're doing bulk insert operations. This means that in the event that you're going ahead and doing a bulk insert operation, the bulk logged recovery model will prevent the database transaction log file from blowing up because it's trying to log each and every row individually. The simple recovery model is, as its name suggests, the simplest and easiest recovery model to maintain. The reason for this is because it does not really maintain a history or a state change as far as the data is concerned. By this, what we mean is that if you choose a simple recovery model, you lose the ability to restore the database to a point in time. If you choose a simple recovery model, the database would only be able to restore to the last known backup that you had taken, which is working. Whereas on the other hand, with the full recovery model, you have the ability to back up the log file, and therefore you also have the ability to change the state of the data, or basically restore to a point in time. For the purpose of this demonstration, we're going to use a simple recovery model and then press OK. Let's go ahead now and take the actual full database backup. Right click on the database and then go to Tasks followed by Backup. At this point, you should have a screen that looks similar to the one that you're seeing on the screen right now. As you can see, we've got the recovery model here as simple, and therefore we only have two different options, which are the full and differential as part of the backup type. If you had selected a full recovery model, you would also see transaction log as an option available as part of the backup type. Again, as you can see, we are selecting the AdventureWorks database for backup, so that's already highlighted there. Copy-only backup is a special kind of backup which we will explain in a future video. At this point, because it's a simple recovery model, the only option available for us is to back up the entire database. If you were using a full recovery model, the option to back up file and file groups would also be available. A backup set is a logical container for files that are related to a particular backup. What this means is that assuming that you're taking a backup at the beginning of the week followed by differential backups once for every day, then the combined 7 set of files, including the first full backup and 6 subsequent differential backups, become part of the database backup set. Logically, this means that in order to be able to restore the database to any point in time or any date of the day of that week, you would need to go ahead and use the files belonging to this backup set. As a result, you also have the option to expire a backup set after a set number of days. This makes sure that you don't really use irrelevant backup sets as part of the restore operation. The next thing that you might want to see here is that we've got the destination, and then we've got the option to back up to disk. At this moment, I am backing up the files to the default location, which is the backup folder in the SQL and program files Microsoft SQL Server installation folder. Occasionally, you might see that you've got a number of files generated here as part of the database backup. This is especially true if you're taking backups of very large databases in excess of hundreds of GBs. At that point, you don't want the backup to be a single huge file spanning over 200 or 300 gigabytes. Instead, you might choose to split the file into a number of smaller backup files that would allow you to transfer them safely and securely over the internet without really having to experience things like timeouts and stuff like that. So it's generally a good idea if you have very large backups to go or very large databases to go ahead and add additional files here with different file names so that you can split a huge database into a number of smaller backup files. You can also go ahead and compress the file, as I'll show you later. The Options tab basically gives you some additional information or ability or operations that you can perform with the backup. As you can see, the backup set that we have can be appended to in case you're adding new differential files, or overwritten in case you're adding a new file or a new backup set altogether. You can also go ahead and then perform a couple of checks in terms of verifying the backup set and performing checksum just to make sure that the backup is valid. At this point, we're doing a backup of the database using simple recovery model, so we don't have transaction log options here. And I'm going to go ahead and choose compressed database backup to just reduce the size of the database itself. Go ahead and press OK. As you can see here, it's going ahead and taking the backup. The percentages show you how far along it is, and once it's done, you'll get a message saying that the database was successfully backed up. With this, we've gone ahead and successfully performed a full database backup. In the next video, we will look at how to restore this backup and bring the database back online.